Alright, so today we're going to be doing solving exponential equations. So key concepts and main ideas. In an exponential equations, variables occur as exponents. Solving exponential equations and using common bases. So the first step is to isolate the exponential term, rewrite each side with a like base, and set exponent equal to exponent, and then solve for x. So I also provided you a table of common bases. So for example, 81 can be rewritten as 3 to the 4th power, 27 can be rewritten as 3 to the 3rd power, and so on. So that's what we're going to be basing it off today. So best way for me to show you is to just do an example with you. So the main idea is we need to rewrite the left and the right side so they have the same base. Base is the number that is to the exponent, okay? So what's another way I could write 9? 3 to the what power?
Second.
Good, so I can rewrite 9 as 3 to the 2nd power. And what's another way to write 27 if the base is 3?
3 to the 3rd power.
3 to the 3rd power, okay? Now, once you've maintained the same base, what you're going to do is you're going to set the exponents equal to each other. So keep in mind, this is really 2 times 2x, which is what?
4.
4x is equal to what? 3. You divide both sides by 4, and you get x equals 3 to the 4th power. Now that's it. So we're going to do a few more examples of this as well. You ready to try number 2?
Hold on.
So the next one we're going to do is number 2. So first thing we need to do is rewrite so we have the same bases. Now I'm going to keep this base as 3, but I know I can rewrite 27 as what? 3 to the 3rd power. Now I can set the exponents equal because I have the same base. So that's going to be 2x is equal to, what's 3 times 2x?
6x.
Good. And now you're just solving for x. Make sense? So the goal is to get like bases. Like bases. And then the rest is just simple algebra. And try number 3. So I want to get like bases. So what's another way to write 16?
4 to the 2 power.
Good. 4 to the 2nd power. And am I going to change the 4?
Change it to 2 or just not?
You could if you wanted to, and you could also, then you'd have to change this.
Oh, yeah.
So it would also be correct. Like you could do it that way, but I just picked the path of least resistance. So there are multiple ways to do it. So is everybody in understanding of why we're doing this with the 4? So now, when we go to multiply this, we have to use the distributive property because there's 2 terms. So this is going to become what? 4y minus 6 equals y plus 3. So the goal is, once your bases are the same, you just set the exponents equal to each other, okay? So subtract y on both sides. That gives me 3y minus 6 is equal to 1. Add 3 to both sides, divide by 3. Yes. I just don't show all those steps, but if you want to do every step out, feel free to do that. Any questions on why the answer is what it is? All right. So this one's a little bit more tricky because we have a fraction involved. But don't be afraid of it. Anyone remember what is 2 to the negative 1 power? Bless you. 1 over 2, right? That's kind of where we're going with this. So I can rewrite 1 over 2 as 2 to the negative 1 power, right? So whenever you want something to come out of the denominator, you can put it to the negative power if it's already positive power. Now how can I rewrite 8 so that it has a base of 2? 8 to the, or 2 to the?
2 to the third power.
2 to the third. Now I have to multiply those, so I'm going to write it out first and then multiply on this one. We use the distributive property. And then you solve however you feel like you like to solve. I'm going to add 4x on both sides. And then divide by 10. What does negative 4/10 reduce to?
Negative 2 over 5.
Good, negative 2 over 5. So my expectation in this class is that you're able to solve simple equations. Alright, so we'll go through the process of how to set it up, but I do expect that you should be able to solve these without trouble, which I think most of you can. So you ready to move on to a different scope of the topic here? Alright. So now we're going to talk about how we can derive exponential functions. So yesterday we learned about how to work with exponential functions, how to plug in values for x and whatnot and obtain different values, but today we're actually going to come up with our own equation. So we're going to create our own equation based on a graph or points given to us. Okay? So the only thing you need to come up with an equation for an exponential function are 2 points. One of those points has to be the y-intercept. So of the 2 points here given to us about deer population, is one of those the y-intercept? Yeah. So here's the formula you use. You use the formula y equals a times b to the x power. Okay? Y is going to represent whatever a y value is, whichever one we have. A represents your starting point, also known as your y-intercept. And B, we will represent our growth factor, which we don't know yet. And then x, we're going to use a value for x, okay? So here's the thing. Here's how we do it. You identify your y-intercept, and that's going to be your a. So your a is going to be 80. Your y-intercept is always a. Now the other point they give you is going to be our x and our y, okay? So I'm going to plug in for a, x, and y into the equation. So I have 180 is equal to 80 times b to the 6th power. So is everybody good with what I plugged in there? Y, a, and x. Now our goal is to solve for b, so I'm going to divide both sides by 80. And I end up with 2.25 is equal to b to the 6th power. Now here's something that you haven't learned yet. You don't know how to solve for b when we have an exponent like this, right? So here's the way to do it. We use what we call a reciprocal power. What is the reciprocal of 6? 1 over 6. Very good. So what we can do is we can put both sides to the power of 1 over 6. And the reason we do this is, what is 6 times 1/6? 1. So now we just have regular b over here, right? And if we solve this, we now know what b is. So you always use reciprocal power, okay? So you might be wondering, how do I put that in the calculator? So I'm going to talk you through the steps of how to do that. If you have one of these on your desk, that's what I'm going to be using, okay? So here's the way. You're going to type in the base 2.25. You're going to hit the button underneath the off button that says y to the x power. Okay? Then you see the parentheses buttons in the middle of the calculator? You're going to do the first parenthesis, and then 1 divided by 6, close your parenthesis. Okay? Then hit the equal sign. you should get 1.144 and so on. All right, so you have to put the parentheses because you're doing an operation in the exponent. So your answer will come out to be 1.145. Did everybody get that? Okay. You want to do it one more time? Yeah. All right. You're going to type in the base, 2.25. You use the y to the x power. You do the parenthesis, 1 divided by 6. Close the parenthesis, then hit the equal sign. You got it now? Okay. You're welcome. So here's how you write your final answer, because they want to know what the exponential function is. So it's going to be y equals whatever our a was times our b to the power of x. So we just used the formula, but we plug in a and b into it. So now we just came up with our own formula to model that exponential situation. So that was pretty cool. You only need 2 points to model an exponent. Anybody have any questions about that? All right, we're going to try another exponential modeling problem. So Kristen starts an experiment with 7,500 bacteria cells. After 4 hours of exponential growth, there are 2,300 or 23,000 cells. Derive an exponential model that shows the number of bacteria t hours after if the bacteria rate stays the same, basically. So we have our equation. Now the reason I know to use this equation is we're talking about exponential growth, but we don't know a rate. So we have to come up with the rate. We know the rate is going to be our b, or our rate or our growth factor or decay factor. We have to come up with that. Okay? So we have to identify which each of these things represent. We need an a y, and a t. Now you're going to see t and x exchanged for each other all the time. X and t can both be the same thing. You could use x here as well. It just represents time. So what letter is represented by the 7,500? Very good. That's how much you start with. A is always your initial amount. What letter is represented by the 4 hours? Very good. And lastly, what one represents this one right here, the final amount? Good, y. So that's y. All right. So y is always how much you end up with in the end. A is how much you start with, also known as your y-intercept, which is also how much you start with. And then t or x is your time. So now we're going to plug into the formula. We have 23,000 is equal to 7,500 times b to the 4th power. We divide both sides by 7,500, and we end up with approximately 3.067. Now, with exponential functions, you want to try to keep thousandths place or 10,000ths place because it can really change your answer a lot if you change the decimal. You'll see. If you do an example, you'll kind of see how much it affects it. Now, how do we get rid of that 4th power on the b? Good, we got to put both sides to the 1/4. Very good. This cancels out the 4th power. Somebody get that? And that leaves me with b equals. So in your calculator, you're going to do to the power of, so y to the x, parenthesis 1 divided by 4. Thank you. Close parenthesis equals. And what did you get?
1.323.
Good, 1.323. Very good. So that's what you end up with. All right. So from there, we now know b, so we can rewrite our formula. So our formula is going to be y equals our a times our b to the power of x or t, your choice. And that's the final answer. Yes. Oh, okay. Okay. So the next problem, we're going to determine how many bacteria cells can be expected in the sample after 12 hours. So what are we going to do with the formula we just came up with?
Change T.
Good, we're going to plug in T. Because T represents time. So remember, in your calculator, you want to do this first, this operation. So that's y equals, hi, you're good, thank you. We're on 7-3. To the power of 12 times 7,500. I just messed it up, hang on. Okay, and that will give you this very big number. Do you all get that? So why, it was 0.8, why didn't I round it up? Anyone know?
4 decimal points.
It's not that, it has to do with the question. They wanted to know how many bacteria cells.
There can't be 0.8 bacteria.
Exactly, there can't be 0.8. So why didn't I round up instead of down? With point.
Can't add an extra bacteria.
You can't add one that's not there yet, right? If we're talking about how many already exist. Alright, so we're kind of in the middle of one growing at that time. So we have to kind of leave it off at how many are actually there. Does that make sense? Okay. It's kind of weird to think about. Plural. It's definitely more than one. It's a lot. Alright, so the last thing we're going to talk about is periodic compound interest. This is same kind of concept, but we're going into a more financial aspect. Alright, so I want to be really, really clear about when you use this formula and when you don't. You only use this formula if they talk about compounded over a period of time. So compounded weekly, yearly, monthly, daily, whatever it may be. If they do not say the word compounded in your question, you do not use this formula. Is everybody clear of that? Okay. So let's talk about what each of these letters represent in the formula. A represents the final amount of money, big A. P represents principal. Principal is known as how much you start with, the initial amount. R represents annual percentage rate, APR, or the rate itself. So it's always going to be a percentage or a decimal. T is time in years, and N is the number of compounding periods. I gave you a list of a few of them here. Annually means only once a year. Monthly would be 12. Semi-annually is twice a year, and so on. So you use that for N, based on what the question says. Alright, so if we invest $5,500, that's going to be our principal, how much we start with. And then the account pays, this is our APR, R. And it's annual interest compounded weekly. So if it's compounded weekly, how many weeks are in the year? Good, so your N is 52. And the account balance after 5 years, that represents T. So now we're going to plug into the formula. So A of 5 is equal to your P times 1 plus your rate. Now why did I write my rate like that? Over my N. So what do you have to make sure you write your rate as? Yeah, as a fraction or a decimal. You can't leave it as a percent, right? To the power of N times T. Now the good news is you can do this whole calculation in one calculator operation if you want to, if you feel comfortable with it. If you prefer, you can do it in pieces. You can do this division, then do the addition, then you can do the exponent separately and then put it all together. But I'm going to talk you through how to do it in one calculation. Bathroom? Yeah, go ahead. So here's the way I'm going to talk you through it. I'm going to highlight it as I go. So does everybody have the calculator in front of them? Alright, you start with this right here. So you do 0.0275 divided by 52. Once you have that number, you're going to add 1 to that number, okay? Now that you're there, here's where we're going to deal with the exponent. So here's how you do it. You're going to hit that y to the x button, parenthesis, 52 times 5, close parenthesis, and then hit the equal sign. You should end up with like 1.147 something. Now, you're going to multiply that amount by this. And ultimately, you should end up with, oh, I saw them on the highlight. $6,310.48. And with money, we always round to the hundredths. Good. Any questions about that? So here's some sad news for everybody. I probably don't know this or think about it. If you have a bank account or whatever money you have invested, if you have multiple decimal places, even if it should round up, they always round down. So say it was like 489, they would round it down to 48. You always lose the penny. So, fun fact. So, the next question. Determine the account balance after 20 years if $100 is placed in an account that pays 1.2% interest, compounded twice a month. So, what does the 20 represent?
Time.
Good, time. 100 represents
Y.
we don't have a y in this formula.
Okay.
P actually. P is how much money you start with. A is going to be how much money you end with.
Oh, okay.
Okay. So now, place in an account that pays, this is your rate, right, your APR. And then if it's compounded twice a month, how many times a year is that occurring?
24.
24. That's a tough one. Do you see why it's 24? Monthly would be 12, but twice a month is 2 times that. So now that we have enough information, we can plug into the formula. A of time is equal to your principal times 1 plus your rate. Don't forget to convert your rate to a decimal over your n, number of times compounded. I'm running out of room, so I'm just going to erase this. And then we have to the power of n times t. So I'm going to go through the whole calculator bit again, just so to make sure everybody's good with it. So I'm going to do this part first. You start with that. 0.012 divided by 24, bless you. Then you're going to add in the 1. Once you've added the 1, you're going to do this part right here. So exponent, parenthesis, 24 times 20, close parenthesis, equals. Then lastly, you will multiply that amount by 100. And you should end up with $127.12. Now I said they don't round up, but we're going to do it for the sake of our problems because that's how it should be, right? Yes.
I didn't get that.
Alright, so on your calculator it's a little bit different, right? So let me end the video and I'll come over and help you. Or actually you come up and I'll help you out with it. Last thing I want to mention before we get into anything else. Before you get into your homework, I just want to give you a slide of how to know what formula to use, which might help you out as you go through the homework.